All right, so using the following information, use the following information to calculate the missing dimension of the cone. Okay, so here we know the surface area is 7,012 millimeters squared, and we know what the diameter is, and we want to try and figure out the slant height. Okay, what do you think a good place to start would be? Yeah. Okay, we could figure out the height. Yeah, I would start with something way simpler. Yeah. Okay, yeah, I would look for the radius, and then I would also do something else. Look at something green. Yep. No, I wouldn't go there yet. I would look at the formula sheet, look at the formula for surface area, and write it down. Okay, when you're working backwards, always start with looking at the formula sheet. See if you have a formula for the surface area of whatever shape you're looking at, write it down. Okay, so yeah, the fact that we have the diameter instead of the radius, that's a step we're going to have to take. So for sure, you need to write down that the radius is 24 millimeters. Okay, but then look at the formula sheet and you will see the surface area of a cone is pi rs plus pi r squared. Okay, how many unknowns are there in this formula? Okay, right now one, yes, but like looking at the whole thing, pretend we're not doing this example. How many possible unknowns are there? How many unknowns? Yeah.
There are 3 possible.
Correct, 3. One of them's the surface area, one of them's the radius, and one of them's the slant height. Okay? As long as you know 2 out of 3, or all but 1 in general, you can figure out the missing one. So once you get this down, figure out what you know and what you don't know, and substitute in values for what you know. Okay, so the next step is we're going to substitute in. So we know the surface area, so I'm going to replace this. 7,012 equals pi. Do we know the radius? Yep, that's 24. Times 24. We don't know the slant height. Times s. Plus pi times 24 squared. Okay? All right, now what would you do? What next? Yep.
I would solve pi, or I'd solve the pi r squared first.
Okay, yeah, so I would not solve but evaluate, right? Figure out how much is this, and also maybe figure out this coefficient. Right, what is 24 times pi? So I'm just going to take out a calculator, and we'll do that quickly, and then we can sub that in. Now, you don't have to do this. You could actually evaluate everything at the end. I know in physics, a lot of times you'll do that in a physics question, or perhaps you may even solve for the unknown variable first, and then sub in. But let's see, okay, so pi times 24 squared equals, okay, so that's 1,809.56, let's say, because I'm not sure, what does it say? Oh, it doesn't say how many decimal places we want. Okay, well, let's keep 3 then. So that's 1,809.557. So this is, oh, does it? What does it say?
But it's kind of different, but it says to the tenth of an inch, you can have this happen.
Oh, so, okay, so to the nearest tenth, let's say. Okay, plus 1,809.557 is, so let's do that. 24 pi, 0.398. So this is 75.398 S. Okay? All right, now what should we do? What do you think we should do next? This is very similar to solving an equation like 5 equals 2x plus 1, but there's some decimals. Yeah. Yeah, exactly. This term needs to be isolated before we can solve for s. So we're going to subtract 1,809.557, 1809. Okay, and that will give us, let's see, okay, so 7,012 minus 1,809.557. That's 5,202.443. What was it? 5,000? I can't remember. I have such a bad memory. This is terrible. 5,202.443. Okay. 202.443. And then what? Yeah, divide by 75.398. Okay, and that is, now I have that answer in my calculator, so I can just use the answer button, which is over here, and then I don't have to retype it. 75.398. And that is basically it would be 69.0 to the nearest tenth. Okay, 69.0 millimeters. Okay, does that make sense? Yep, yes. Yeah, we're going to do the first one now. Or did you have a question first? Okay, so I do want to track back to this first one because this one actually involves a little bit more work. So a model of the Great Pyramid of Giza is constructed for a museum display. The lateral area of the triangular faces is 3,000 square inches. The side length of the base is 50 inches. Determine the height of the model to the nearest tenth of an inch. Okay, where would you start here? What's the first thing you might do? Yeah.
Form a sheet and draw it.
Yeah, draw it. Excellent. I would draw this thing. Okay, so we know it's a square pyramid. And here we go. Okay, it's a square pyramid. The side length of the base is 50 inches. So this is 50 and 50 because it's a square. Okay, the lateral area of the triangular faces is 3,000. So what does that mean? Yeah.
The area of the pyramid without the base.
Yeah. The area of the pyramid without the base. So that's talking about 4 triangles, right? So 4 triangles is 3,000 inches squared. Okay. Could we figure out the area of 1 triangle? Yeah. What do we need to do? Divide by 4. So if we divide this by 4, I think that's 750 square inches. Okay, do we have a formula for the area of a triangle? Yes, it's base times height divided by 2. Now this is where we have to be careful though, because in the pyramid, the height of the triangle represents what? There's the height of the triangle. What does that represent in the pyramid? Yeah.
Would it be the center?
No, it's the slant height. Yeah. So this is actually the slant height. So right now we know the base is 50, we know the area, we have the ability to find the slant height. What we're asked for though is the height of the pyramid, right? That's actually this height. Okay? If we know the slant height, could we figure out the height? Yes, what would we have to use? Pythagorean, yes, exactly. So what we're going to do, you kind of have to make a roadmap. What can I get here? I can get the slant height because this is basically base times height divided by 2 is equal to 750. And the base we know is 50, right? So we can fill that in. And this is, I'm actually going to put an SH here for slant height, okay? Because I want to sort of distinguish the two. That's 50 times the slant height over 2 is 750, okay? And that's 25 times the slant height is 750. So now we're able to find the slant height. And I believe that comes out to be 30 inches. Okay, so really important to have a diagram here because honestly, I would have a really hard time visualizing this if I couldn't see it. All right, and that's really because the height of the pyramid is a three-dimensional height that runs through the center of it. It's not on the surface at all. So we're using surface area to try and figure it out, but it's really hard to see the height like if you just had a net. Okay. All right, so now that we know that this is 30, how much is this part? 25, right? So now we have the ability to find the height. So this is kind of step one. To find the height, I would actually redraw that triangle, make this 25, this is 30, and this is the height. Yes?
Would the way you represent the Pythagorean theorem be 25 squared plus b squared equals 30 squared?
Yes, exactly, because that's, the 30 is actually the hypotenuse. So right now what we know is the hypotenuse in one of the shorter sides, and we're trying to find the other shorter side. Okay, so yeah, you have to be, a lot of people make mistakes with the Pythagorean theorem because they assume that the unknown is the c squared part. And that's only actually true about a third of the time, right? Because there's three sides to the triangle. There's like a 1 in 3 chance that it's going to be the hypotenuse. Yep.
Could it be 30 squared minus 25 squared?
Yeah, so I know a lot of people learn it that way. I always kind of model it with starting with this. That's going to be a step. And the reason why I model it like this is because that's what's given to you on your formula sheet. So I know in junior high, a lot of teachers will give you 3 versions of the formula, a squared plus b squared equals c squared, or a squared equals c squared minus b squared, or b squared equals c squared minus a squared. And that's totally fine, and if you remember that, that's a-okay, but you're not going to get 3 versions, okay? So if we fill this in, we're going to get h squared plus 25 squared equals c squared, or sorry, 30 squared. And at this point, you could either evaluate these and then subtract, or you could subtract right away, right? So if you subtract 25 squared from both sides, then you're going to get h squared equals 30 squared minus 25 squared. And that is, let's see. It's 900 minus 625, 275. There we go. So we can find h now. It's the square root of 275. Okay, so I'm just going to go into my calculator and take the square root of that, square root of the answer, because I don't feel like retyping, and that's to the nearest tenth of an inch, 16.6 inches. Okay? All right. The thing that I really want to stress with this example, though, is make sure to draw it. Okay. All right, so I'm going to give you guys a couple minutes to try some questions. Oh, no, there's one more. Never mind. And then you guys can try a couple. Okay, so here's another one. The surface area of a lacrosse ball is approximately 20 square inches. What is the diameter of the lacrosse ball to the nearest tenth of an inch? Okay, where would you start with this one? Yep. Yes, write down the formula for the surface area of a sphere. And that is that surface area equals pi r squared. Okay, now we're being asked for the diameter of this ball, but if we could figure out the radius, we can very easily get the diameter. Okay, so that's going to be sort of our plan of action. Okay, so let's fill in what we know. Here there are only two unknowns, the surface area and the radius, and we know the surface area. So we'll put this in as 20 equals 4 pi. That's my bad. I copied the equation down wrong. 4 pi r squared. Okay, and what would you do next? We want to figure out r. Yeah. You could do 4 times pi, sure. You could also just divide both sides by 4 pi, right? So some people really like to get rid of that pi and have it as a decimal, and that's totally fine. You can do that. You may, if you go further in math, find that in certain courses you have to have exact values. So I'm going to kind of show you both ways. Okay, so let's say you multiplied 4 pi together. So that's 12.566, let's say, okay? So 20 equals 12.566 r squared. Okay, and then what? What would you do next? Yep. Take it away? What's the operation that's happening here? Yeah, we need to divide, right? And here is where I would really encourage you, instead of to retype that 12.566, use your answer button, because then the calculator will bring all of those extra decimals and your answer will be more exact. Okay, so I'm going to go 20 divided by the answer. And I get 1.592, let's say. Okay, so that gives me r squared equals 1.592. Okay, now how do we get r? Yep, square root it. So r is going to be the square root of that. And again, this is my last answer in my calculator. So I'm just going to actually take the square root of the answer. Okay, and I get 1.2615, or 16 rather. Okay, so r is 1.26, what was it? 15, okay. And it keeps going. Okay, is that my final answer? No. What do I need to find? The diameter. So the diameter is going to be 2 times this. And then again, I'm going to enter that into my calculator. So I'll just go times 2. And I get to the nearest tenth, it's 2.5. Okay, 2.5 inches. Okay, now if you wanted to do this, all of the work before you actually enter anything into your calculator, I want to show you how to do that too, because again, not in this course, but in some courses, you may be asked to show the exact value, and I just think it's easier to figure that out if you've seen it before, and it's not terribly hard. Okay, so we would do it the same way, where we'd start with 20 equals 4 pi r squared, but then instead of evaluating this, we would just go divide by 4 pi. Oh, yeah.
Can we write our names on them?
You can write your names on them, but you can't write anything else, or else I'd have to give you a new one in an assessment. Okay? Okay, so if we do this, then 20 over 4 pi, the 20 over 4 cancels to 5 over 1. So I can make this 5 over pi equals r squared. Okay, now how would I get r? Yeah, square root it. So r is going to be the square root of 5 over pi. And then if I wanted diameter, what would I have to do to this? Multiply by 2. So d is 2 times the square root of 5 over pi. And then if you needed to, you could enter that into your calculator. Does that make sense? Okay. All right. Now I'm going to get you guys to try some of these guys yourself. So there's 3 questions here for you to try, and then we will do a couple more problems in a few minutes. Essentially, when you take 2 or more 3-dimensional shapes and you stick them together. And for surface area, that can get a little complicated because as soon as you stick things together, you've covered up some exposed surfaces. Okay? And then the other thing that we have to keep in mind when we're talking about surface area of composite objects is what type of object is this? If it's a building, it's going to be stuck to the ground, and so the ground will not be visible. Right? So you have to really pay attention to detail and think about what is actually being exposed and be able to sort of pick apart those different surfaces. Yeah?
So if that was a building, would you just take the lateral area of both of those?
So if it's a building, you wouldn't exactly take the lateral area because the lateral area means, well, it depends. If it's a pyramid, yes. If it's a prism, then lateral area means you take off both ends.
Since those are like connected at the top, those 2 shapes, would that be the lateral area?
Sort of. We're going to talk about it. There's the thing with composite objects is that I can't give you a rule that covers everything. The problems are very, very individual, and what you really have to have a sense of to be able to answer these correctly is what does each part of the formula for each shape represent? Because almost always with these types of problems, you're taking out specific surfaces. Okay? Now, what I would encourage you to do, though, is start out by looking at the shape and seeing which surfaces are actually exposed. So right here, we have a cylinder with a hemisphere on top of it. Okay, we're not told that this is like a building or anything like that. And in fact, it's fairly small. It's 4 feet in height, and then it's got a 2-foot radius. So this is probably something that you could lift off the ground. So we're just going to assume that the base could be exposed. Okay, so when I'm looking at this, I'm looking at all of the surfaces that could be exposed, and I can count 3 of them. So there's the base, which looks like this, right? It's a circle. There's the tube part, which is a rectangle. And then there's the hemisphere, which is like that. And it's just the outside of the hemisphere that is exposed. Okay, so my personal strategy is to actually almost make like a net or pick the exposed surfaces apart and calculate each one and then add them all together. Okay, or you could even just write the formula for each one, right? So this base, the formula for the base is that area is pi r squared. So here, area is pi r squared. For the tube part, what would the area of that be? You may need to refer to your formula sheet to figure this out. Yeah. Okay, it's length times width, but we don't actually have a length and a width in this diagram. So we really have to think about pieces of the object that we have. Yeah. Yeah, so this is the circumference over here. The length is the circumference. This is the height. But you do have that expression on your formula sheet. It's the lateral area of a cylinder, right? So you don't have to come up with these from scratch. You can use your formula sheet. You just have to have an understanding of what each piece of the formula represents in the 3D object, right? So this is 2 pi r times h, 2 pi r h. Because again, this is the height, and this is the circumference, which is 2 pi r. Okay? But yeah, you don't have to memorize that, but you do have to understand the formula. Okay? And then the hemisphere is half a sphere, so this is going to be 2 pi r squared. Okay? And then if you want to put this all together and do it all in one calculation, you could just add the three of them together and then do it all in your calculator at the same time. So all together, the surface area is going to be pi r squared plus 2 pi r h plus 2 pi r squared. And then fill in all of your values. So r is 2 pi times 2 squared plus 2 pi times the radius is 2 times the height is 4 plus 2 pi r squared, and again, r is 2. Okay, and then you can take out your calculator and do that all in one go. And so that's pi r squared plus 2 pi times the radius, which is 2, times the height, which is 4, 2 pi r h, plus 2 pi r squared. Okay, and then that comes out to be 87.96, so I can't, what were we asked to round to here? Nearest square foot, so that's 88 square feet. Okay, so you can do it this way. Some people actually like to find the individual areas first and sub in your values for the individual areas and then add them together. That's fine too. Yes?
I was just wondering if we were going to have any time today to work on the homework.
Hopefully we have one more question to get through, and then you guys will have the rest of class. Okay? All right, so here's the next one, and this is the last one that we'll do today. A cabane de sucre is I can't speak French, please pardon my terrible accent, is a composite object formed by a rectangular prism with a right triangular prism as its roof. Determine the surface area of the cabane de sucre in yards squared, square yards. Okay, so this is a building, right? It's actually something that they have in Quebec where they make like candy out of maple syrup on snow. I'm not sure if you guys have ever seen those, or had that. It's very delicious. But there's not going to be an exposed base. It's stuck to the ground, okay? So we're not going to take the bottom of this thing. So what we need to do is figure out what sides are exposed and then calculate the area of all of those, okay? So in terms of the rectangular prism, the base is not exposed. What about the top of the rectangular prism? Is that exposed? Right? The rectangular prism is the rectangle part. It looks like this. So the base is on the ground. What about the top? No, it's not exposed either because it's covered up by this roof. So really for the rectangular prism, we're just looking at the four walls. Okay? So for the rectangular prism, we got the four walls. And the front and back is 2 yards by 3 yards. And there's 2 of them. It's 2 times length times width, which is 2 times 3. And the multiplication by 2 is because there's 2 identical walls. Okay, and then if we have the 2 sides, the right and left side, there's 2 of those. And then what are the dimensions of the side walls? Yeah.
5 by 2?
Yes. So this is 2, and this is 5. So each of those rectangles are 2 by 5, or 5 by 2. Okay, so that's the rectangular prism part. For the triangular prism roof, we basically have 2 triangles and then the 2 slanted rectangles that make up the sides of the roof. Okay, so for the triangular prism, we have the 2 triangles and the 2 slanted rectangles. Okay, now the triangles are base times height divided by 2. So we know that this base is 3 and the height is 2. So we can figure out these guys. That's 2 times base times height over 2. So the base is 3 times the height is 2 over 2. Do we have enough information to figure out the slanted rectangles part of the roof? Yeah? Okay, so this is 5. We know that, that's the length. What's this? Do we know that length? Yeah?
We don't, we can find the slant height.
Right, we can use the Pythagorean Theorem to get this dimension, okay? So for the slanted rectangles, we actually have to do a little bit of work first. So I'm gonna redraw this triangle, and if I am just looking at this right triangle, okay, this is only 1.5 because it's half of the base, and then this is 2. So we're looking at this. I'm going to call this W for the width of that rectangle. Okay, and we do have to figure out what that is. So we're going to use Pythagorean Theorem. 2 squared plus 1.5 squared is W squared. And that works out to be, I'm just going to do this on my calculator over here. 2 squared plus 1.5 squared. I think it's 6.25. Yeah, 6.25 equals W squared. So W is going to be the square root of that. And I think, what is that? It's 2.5. Okay, so for these 2 rectangles, the area is going to be, the length here is 5 and the width is 2.5. So the area of the rectangles is 2 times 2.5 times 5. Add everything up. Okay, so let's just do this sort of one by one. This guy, I'll do this in a different color maybe, is 2 times 2 is 4 times 3 is 12. This is 2 times 2 is 4 times 5 is 20. This is, 3 times 2 is 6 divided by 2 is 3. So 2 times 3 is 6. And then 2 times 2.5 is 5. Times 5 again is 25. So the total surface area is the sum of all of those. 12 plus 20 plus 6 plus 25. Whatever that comes out to be. I don't know. 32, 38, 63, you think? Okay. So really important is to show a lot of work, really break things down, don't try and skip steps because it's the devil sort of in the details for these problems. Okay, so I'm going to end it there today. There are a couple questions on the next page that you can try, or you could start working on your homework.